I'd like to, at this point, turn it over to the long conversation and ask our first two conversationalists to join us. We have the amazing David Rubenstein, TV interviewer, philanthropist, history buff, and chair of the Smithsonian Board of Regents, talking to Sabrina, who is an amazing millennial phenomenon. She is studying theoretical physics at Harvard, something called quantum gravity, which I don't pretend to understand, and she's going to hate me if I say this because she hates it, but has been called the next Einstein by Harvard, so no pressure there. Definitely makes me feel like a slacker, and with that I say thank you, and please enjoy the conversation. Thank you.
Okay, well, thank you very much for coming. So, can you live up to the billing of being the next Einstein, or is that a little bit too much?
No.
So, do you think Einstein's overrated?
What? No. I think that his name is overused.
Okay. So, how did you get interested in theoretical physics?
So I was interested in aerospace engineering when I was little, and then I just wanted to kind of have more of an understanding of whatever it was that I was doing, and theoretical physics is a nice balance of.
Okay, and so you did extremely well in high school, I assume?
Sure, did good.
And
great.
you went to MIT?
Yes.
And how did you do at MIT?
Great at MIT.
You get and you get a B?
No.
Only
See, the
A's.
thing about it is you work really hard to get like good grades, but in the end, like, that's not enough. And so, like, part of the reason I'm here today, which I'm really excited about, is that you go through your undergrad, you do your curriculum, and you realize that there's, like, so much more that you need to actually learn, especially once you're in a graduate program, say. And nowadays, online, you can watch a lot of courses that you just happen to not sit in on.
So when you went to MIT, how many women were majoring in theoretical physics?
Probably a good number. I mean, I think there were 80 in our class, and maybe just less than half were female.
And did you think the people at MIT were as smart as you thought they were going to be?
I think it's a difficult question. I mean, like, you don't know how smart is anybody. You don't know, like, have any, like, standard. I mean, one thing we did have, we had histograms, and that was kind of fun to see how you did on any given test. And it's more makes you feel better about yourself, but it shouldn't. You know, I was waitlisted when I got in, and then I, like, tried to do really well, and I did because I had a reason to, but it's not everything, it really.
Okay, so what is quantum gravity?
Okay, so that, when I say that our research is related to that, it's because you put yourself under this umbrella of what are the unsolved, say, questions that are sitting around for you to tackle. So for us, you have a consistent theory of what you would see at the LHC. So quantum field theory describes a lot of things, but then you're unable to necessarily have a consistent theory where you take Einstein's equations, put them into the form of a Lagrangian, and so you have this equation where you can't really quite mix it with a quantum theory. So the fact that there is this kind of mismatch is what leads people to say string theory or some other solutions where you have this graviton, you have this theory of gravity coming out of a theory that's inherently quantum.
Now, if Einstein had never lived, you think that the special theory of relativity and the general theory of relativity would have been discovered by somebody else within 5 years, 10 years, 20 years, or maybe never?
I don't know the time frame of what people think. I mean, from the point of view of in hindsight, everything is much more like, let's write down everything that's covariant, and this is like the simplest action with two derivatives, say, like, that you can write down. So, you know, like, the way that things are seen later, you can take a first-year graduate course and learn general relativity, but that doesn't mean you know how someone's going to come up with something.
Okay, so Einstein had a reputation for being a little absent-minded. He was very smart, a little absent-minded. And do you think that's a trait of theoretical physicists, or not really?
I think you're trying to figure that out right now. Okay,
right, I am. Here I am. So, explain to me, what is a black hole?
Okay, so the stuff that I care about is radiation that is sent really far away. So, like, you take some charges and you shake them up, and then they radiate because you learned in undergrad, say, about Maxwell's equations. Really far away, you're going to see the radiation hit you. Now, when you have a black hole, so say now you have Einstein's equations that says if I have a certain stress tensor, now do I have, like, what's the metric? What's the, like, if I stand on a trampoline, what will the shape of the trampoline be? Right? So you can find some solutions where literally light cannot escape from some region. And so now you have this horizon, and the black hole is like the reason behind it.
So why should the average person on the face of the Earth care about whether they're black holes or not?
They might not need to.
Or they shouldn't care?
I mean, like, you shouldn't, like, people should care about other people too. I mean, like, there's a lot of things people don't care about that they should care about, and a lot of things people care about that they shouldn't care about. I care about this. I think it's good that people do care about it, but I don't think you need to tell everybody that you need to know all of these different facts about physics, because physics isn't about facts.
Right, you believe in the Big Bang Theory?
Understanding. Yeah, I think I do. I mean, I believe in what I'm taught. I don't study in particular the details of like all the different like stages of like Big Bang nucleosynthesis or whatnot for my particular research, but yeah.
So what makes you optimistic about the future? You're a graduate student at Harvard. I don't know if that makes you optimistic or not, but are you optimistic about the future, and why?
I'm optimistic about the ability to go back and learn what you didn't learn, because obviously there's huge like holes in your knowledge especially when you're going through a graduate program or whatnot. And now basically a lot of courses are being put online. You can just watch them on YouTube and catch up. And that's what makes me excited, because that's something where it's like, as a student, I know I will benefit from this, and I know this can get better. When people give talks, they say, oh, this citing this paper or another, and they start the talk, but you don't have any way to search that later online. So things like that are going to get better. And that makes me happy, because I know that I can get direct from the source instead of necessarily.
So when are you, what age were you when you graduated from MIT?
I think 20. I mean, it's like 19 to 20.
19, 20. And when you're going to get your PhD, how old will you be?
Oh, I'm 24 now, so 25.
And so then what are you going to do with a PhD? You're going to teach, you're going to do research, you're going to go into private equity, something important like that?
No. Definitely, I want to go into academia.
Not private equity, no investments, no? Okay.
Invest in myself.
Okay, so, all right, so you're going to teach and do research?
Hope so.
And what do you hope to accomplish that would make your career successful? In other words, is there something you want to discover? Is there something that you want to accomplish?
I just want to understand more. And the thing about, so like when you do theoretical physics, it's often like, it's just silly questions in hindsight that you're excited about, but like when you make a contribution, it's really thrilling. For like whatever moment you think you made a contribution, and whether or not you did, like a day later, that might change, because you understand better what you were playing with. But the kind of that joy is what I like, and then studying more to like actually be able to contribute to what other people don't know is something that's exciting and I look forward to. But if I could say exactly what I was going to do, I'd probably be able to do it already, because like literally, like you have these open questions and you can say you're going to tackle them, but if nobody's tackled them and figured it out correctly in the past, odds are not in their favor that you're going to use the current tools to solve them. So you're basically looking for new tools that hopefully will go back and address those.
Now, both your parents are lawyers, is that right?
Yep.
So are they disappointed you're not going to law school?
No, they're happy.
They're happy?
Yeah.
They're happy you're a theoretical physicist?
They're happy I'm not a lawyer.
Okay. Okay. What do they think about private equity? You didn't ask them. Okay. So today, what do you do for relaxation? I mean, you can't do theoretical physics 24 hours a day, I presume.
I mean, I basically sing or sleep.
Well, like, do you have a musical instrument?
Just boy. Because that way you can stay in the department late at night, nobody's around at like midnight, there's a security guard who's there, and that's how I relax.
Okay, and so today, are you writing papers now that you're publishing?
Yeah, I mean, with other people. It's not a solo act. I'm a wonderful advisor.
Can the average layperson understand what you're writing, do you think?
But even in theoretical physics, the point is that if it's easy to understand, then it's not technical enough to be a paper that you put on the archive or in a journal.
Okay, so when you took the SATs, did you have a tutor, or you didn't need a tutor?
No. I mean, I didn't have a tutor.
You didn't have any tutors?
No.
Did you get a perfect score on your SATs?
No.
Oh, really? What? You made one or two mistakes or something?
I mean, I could look back at it, but the thing is that there's like these metrics that you try to use to like say how good people are don't really end up doing any good, because you can look all like great when you're like set up. You know, like I have great grades. I had good SATs, not perfect SATs, so I can't join the 2400 club or 1600 now that they got rid of.
So if you hadn't gone to MIT, where would you have gone to school?
I actually only applied to Harvard, MIT, and I got rejected at Harvard and waitlisted at MIT. So I don't know what I would have done for a year when I got in waitlisted. Yeah. I mean, I think I was gonna like.
Did you call the Harvard people and tell them they made a mistake?
No, I did. I wouldn't do that myself.
You wouldn't do that?
No. But I did have a lot of people. So I got in this. I had some friends who were like, you know, closer up to the Harvard people, and they'd send like magazines or whatever. That helped me because I did well in high school, and I got on this like magazine cover.
So your fellow college and graduate students, are they optimistic about the future generally, or are they pessimistic, or what do they think about the future?
Depends on their department.
Which the economists are pessimistic and the physicists are optimistic, or?
Even maybe within the subfield, I think that there's a different sense of optimism when, like, there's optimism where you know that all the bad things that are going on in the world will not affect you in the short term. That's a different type of optimism. Or there's ones where, like your field is at like a stage where there's a lot of things coming out. And theoretical physics is less like that, so you have more time to catch up, and that makes me optimistic.
So do theoretical physicists have a good sense of humor? Are they joking around a lot, or they're just too serious to joke around?
I think they're trying to figure this out again. I mean, for me, I don't know how funny I am or that. Like, I can't even speak.
There are no big theoretical physicist jokes or anything like that?
No, the worst is they always do, like, they'll say something and they'll say pun was not intended, and, like, the pun was definitely intended. Like, they really thought it out, and it's great. Like, you made a joke. But, like, saying the pun isn't intended.
Most people don't get the joke unless
no, we get the joke at this because they say it, like, that it was a joke.
Okay, so today, graduate students today, are they worried about public policy? Do you see them worried about what's going on in Washington very much, or they don't care?
I mean, the lunch conversations are all about politics. Like, I mean, and when they're not about physics, it's politics. And it takes up a lot more time than you'd like it to, but it's, you know,
what's going on in politics makes them optimistic, or no? Really?
Does it make you optimistic?
So they're not optimistic?
No, they're optimistic, but they're optimistic because we're in a little bit of a bubble that we can enjoy and that we can play with, for now.
So when you graduate, you're going to stay in the East Coast, or do you want to go back? You're from Chicago, right?
Like, there are a lot of really great institutions on the East Coast, so.
And had you ever been to the Smithsonian before?
I don't think so.
No, you never came. Your parents never brought you here.
We're in Chicago.
Well,
we've been on field trips, like, in Chicago.
they have trains, they have planes, they can get here, but they never brought you here. Okay. So are you going to visit any parts of the Smithsonian while you're here, or you have no chance, no time?
I guess there's some people who are going to usher us on and off stage who can decide that for us.
Okay. And today, what would you say that you've accomplished in your life so far, other than this interview, about which you're most proud?
Most proud? Ew. I think that I am happiest that I have a lot of time still to learn. I don't think I'm really, like, proud of anything in particular. I'm just, like...
So you have role models?
Yeah, basically a little bit of everybody, right? You look in the mirror, you see where you want to see yourself, and that's, like, your role model. It doesn't have to be a person who did something, because if somebody already did exactly what you want to do, what's the point in doing it? So...
That's an unusual view of a role model. So you don't have any one person that you really look up to?
No, because that would be kind of, I mean, you're never going to live up exactly to that person. You're just, like, setting yourself up for a disappointment.
So Albert Einstein, do you know much about him, or not that much?
We know people through their equations. So, like, yes, we use Einstein's equations.
So if somebody said to you, I don't understand theoretical physics, explain to me what E equals mc squared really means, what would you say quickly?
I like E equals gamma mc squared. I mean, in the sense that, so essentially the nice thing about that statement is that you're taking the time-like component of a 4-vector, where when you then rotate or boost, you get the kinetic energy that you'd study in high school, like 1/2 mv squared. So saying mass is equal to energy is what that literally is saying, but
okay.
More fun.
All right, and so Albert Einstein's hair, for example, seemed to be askew. That's not a common trait of physicists, right?
Oh, no. We can't afford hairdressers like you probably can.
Okay. All right. So today, as you look at the future, do you think that people of your age have a better situation in the next 10 or 15 years than people of my age did in terms of the optimism?
Well, maybe not optimism. I mean, when things are looking not so good, people kind of rise to the occasion, so maybe we're lucky for that, but I mean, you go back more than 10 years and you're back in that situation. So, but I would say that we have a lot more tools at our fingertips very quickly. And what helps when you go to graduate school is, like, are you ready right away to do research, say, or do you have a lot to learn beforehand? So, like, basically any step ahead that you can have before people see you the first time and realize this is what they're dealing with, like, the better off you are. So the fact that there's more stuff just available online where you can catch up and, like, study advanced level courses before you technically need to puts you at an advantage where you can probably work more with, like, people who are, like, leaders in the field and in a better position.
So sometimes people who have scientific backgrounds these days go into something called venture capital.
Yeah.
They try to create new companies that change the world.
Yeah.
And they make some money as well. Do you have any interest in going into venture capital?
Okay, what if I told you I wanted to, like, start a company, and then you asked me what my company is? I have no idea.
Well, you don't have to know right away.
To have a goal in mind that you're going to start something where that thing is not there is, like, great. But to basically, I mean, that's one thing nice about theoretical physics is that you don't have to have exactly what you're going to solve in your mind when you go pitch it to, like, getting into grad. I mean, for some fields you do, kind of, your thesis. But like the whole point is that you have something where in the meantime, if you don't have something that great, you can learn. You have something to do that's going to help you get to a place where you're going to do that. Versus, you know, if you're the business school kid looking out for like these MIT freshmen who are going to like give them a company so that they can like become the CEO, you know, is that really what you want?
So you're probably not going to go into venture capital.
I mean, I have friends who do that, but like.
So what is the most common thing that graduate students of all types, theoretical physics, economists, talk about today? Are they worried about public policy? Are they worried about the internet, the smartphone quality? What are the most common thing that people your age are talking about?
When I'm in grad school, the only people I interact with are the people like on my floor in my subfield at Harvard. So I can tell you what the postdocs and the faculty and the grad students who do the same thing as me talk about, but it probably isn't going to be very reflective because we're in a bubble. First of all, we're in the academic, like city bubble, so, you know.
All right, and so you're pretty much in a theoretical physics bubble?
Yeah.
Okay, and can you explain in simply what string theory is?
So, I mean, so the fun thing about what I'm not, like, I don't, my research does not contribute to string theory. We take courses, we read textbooks because we want to learn more about it, and eventually maybe one day we'll do research on it. But essentially it's kind of fun in the sense that if you start from instead of a point-like object and you can like give you a cookbook with the interactions that these different particles can have, you can keep adding different, say, up to like some anomalies or whatever, consistency conditions, different particles to your theory and keep going. Versus when you have something where you're starting with a string, you're literally like talking about like normal mode vibrating and now you have some superspace version of it. You can get the particle content out of it. So it's kind of fun how like a theory can be built with fewer parameters. And that's what's like elegant about it. Also the fact that you get.
So going forward 50 years from today,
yeah.
if somebody were writing about what you accomplished over the prior 50 years with your life, what would you want people to say that you did in the prior 50 years?
I don't think I would know. I mean, the thing is, I guarantee I can make myself look much more of a fool saying exactly what I think I want to do than I could saying I don't know, because it's probably more likely that I have no clue what's going to be said. If people are saying anything about me in 50 years, it's probably a good thing, you know.
And you hope to stay living in the United States, or do you want to live anywhere else?
For academia, the U.S. is leading.
Okay. And is the United States the leading place for theoretical physics in the world?
Yes.
What's second?
See, the funding is like somewhat of an issue. I think that it'd be really cool to be at like ETH or in the UK, say, but I mean, like the US just has a lot of places to be. And I mean, it's easier also to, as soon as there are a couple good, really great people at IAS, like, wherever they travel to, say, like you want to be in that circuit.
And is there anything the US government can do to help theoretical physicists? Is there more funding, or what can the US government do?
I mean, I think continued funding is good because like, nowadays there are a lot of private people who are willing to kind of like fund a center. Like you have like Simon Center, or you have like KITP. So when you have these like this private money going in, which is wonderful, like NIS, that's great. But the issue is like you want people to think that that's going to be the future model of support or not, and it shouldn't be. I mean, like there's always you need MSF. You need.
Oh, if Jeff Bezos or Richard Branson came along and said, you know, you're a really smart person, you know a lot about theoretical physics. Why don't you be a passenger in my spaceship, and I'll take you to outer space, and you can see what it's like to go in space. Would you do that?
Well, the point isn't to be the passenger. I think that's the point of theoretical physics. And I interned a little bit at Blue Origin when I was in high school. I think this stuff is really, really cool. But something about theoretical physics drew me into that. And if I were ever involved with the aerospace stuff, I don't think the goal is to like, I mean, you can take a small airplane, like, and literally just nosedive for a little bit, like not like all the way down, and feel 0 G if you want to. So that's, the feeling is there, and you have satellite imagery, so it's fine.
You're an American citizen, right?
Yes.
All right. So what makes you most proud about being an American citizen?
I think the fact that you don't have to think about that. I mean, like everything has been really great for me, and I'm proud that I can get into the undergrad programs here without having a 10% cap on admission, like if you're foreign, and like we're just so different. It doesn't.
So on the scale of 1 to 10, with 1 being the highest,
1 being the highest,
and 10 being the lowest,
okay.
Where would you put yourself on the optimism scale about your future and about the future of this country? 1, 2, 3, 4, 5.
Well, the thing is, I would put it on the more optimistic side of the scale, but if you quote me on putting a 1 in optimism, I guarantee anybody would like repeat that and say that's like a low end of the scale. I mean, I think I'm optimistic. I'm very optimistic. I mean, I am much more optimistic about where I will be than where I am, like as far as like.
And where would you put on a scale of 1 to 10 this interview?
This interview, I mean, it sounded better than it could have been. I mean,
Better
you're like
than it
trying to,
could have been.
no. Before he's like, are you a prodigy? I'm like, no. And he's like trying to ask all these stats about me, and he's like, whoa, you really aren't a prodigy. It's like,
all right.
Yeah, I convinced you.
Thank you. You did a great job. Thanks very much. Thank you. Bye. Thank you.
So now I get to do the grilling? Okay. Tell me what you do.
Tell me what I do.